Hi guys, this is the second half of the analyzing graphs notes that we started last class. So last class we learned about increasing and decreasing intervals, extrema, domain, and range. In today's class we're going to talk about y-intercept / initial condition, as well as x-intercepts and zeros, asymptotes, and NUV. So let's start off with our y-intercept. So y-intercept, sometimes known as our initial condition. Alright, a y-intercept is a point where a graph crosses the y-axis. Alright, so when you cross the y-axis of a graph, that means by crossing the y-axis, right, what's my x-value? Anywhere I cross my x is 0. So this happens when the function is 0. So when x equals 0, we're going to cross our y-axis and create a y-intercept. Oftentimes, this represents the starting point
or initial condition of a scenario, but not always. Okay, so sometimes this happens and sometimes it doesn't. So if you look at our graph here, notice we have a y-intercept, and a y-intercept is going to be a point, a coordinate point. So x comma y is how we're going to put it. So the y-intercept for our graph is at 0, -2. All right, don't just say -2 because I don't know what you're talking about. 0, -2 is our y-intercept. Flip your notes over to the back, and now we're going to look at x-intercepts and zeros. So an x-intercept is, again, a point, remember, x comma y, at which the graph intersects the x-axis. So when you cross the x-axis, again, we're trying to figure out what's the y value. Notice this graph crosses the x-axis at 2 points. So we have 2 x-intercepts. All right, so it's written as a point. Okay, and from our example, those 2 points are -1, 0, and 3, 0. Again, those are coordinate points. So for the term 0, it's a value for which f of x equals 0, or when y equals 0. So when you set your function equal to 0 and solve for x, that will give you your zeros of your function. They're located the same place the x-intercept is located, and you can write your zeros as a point, so -1, 0, and 3, 0, or you can write them as x equals a number. So x equals -1 is one of our zeros, and x equals 3. So notice these are synonyms of each other, x-intercept and zeros. If I ask for either of those two things, you can, well, first of all, x-intercept is a point, just like y-intercept, but for zeros, you can give it to me as x equals a number. The next thing we're going to talk about is asymptotes. So we're going to have vertical and horizontal asymptotes. Later on in the year, we'll see that we can also have slant asymptotes, but we're not going to be super concerned about them right now. So an asymptote is a line or curve that the graph of a relation approaches more and more closely the further the graph is followed. Now, 2 points to note here. A graph will never cross a vertical asymptote, ever. A graph may cross a horizontal asymptote. So those are the differences there. Now let's talk about vertical versus horizontal and take a moment and recap from Algebra 1. So when we're thinking of a vertical asymptote, we're thinking of VUX. That stands for vertical. You have an undefined slope, and it's going to be in the form of x equals a number if you have a vertical asymptote. A horizontal asymptote, we think of HOI. So HOI VUX is the whole saying, but we did them in reverse order. But HOI, horizontal, it's a horizontal line. It's going to have a 0 slope. That's what we think of the O as. And it's going to be in the form of y equals a number. So if we take a look at our example here, you'll notice we have both types of asymptotes. So let's do the vertical one first. So there's my vertical asymptote. I just kind of dotted it in orange there. So remember, vertical VUX, it's going to be in the form of x equals. And what does x equal along this whole line? It equals 0. So that's the equation of a line. For my horizontal, I'm going to kind of dot it in green here. And for my horizontal asymptote, that's my HOI. So it's y equals a number. And what does the y value equal along that whole line? It equals 0. Last topic we're talking about today is end behavior. So when we're talking about end behavior, we're looking at what are the arrows doing, okay? So what are the arrows doing? All right. So when x goes to infinity, our arrow is going to the right. Okay, when x is going to negative infinity, our arrows are going to the left. When f of x, you can also think of that as y equals, okay, those are synonyms of each other, but we've moved on from just y equals to, it could be any function. So f of x approaches infinity, that's when we're looking up, and when f of x approaches negative infinity, that's when we're looking down. So if you take a look at our first graph, our quadratic that we've used the whole time, notice this arrow right here is going up and to the left, whereas this arrow is going up and to the right. So this is how we describe our end behavior. We describe it kind of like in the form of a sentence. So as x approaches negative infinity. Why is it negative infinity? Because I'm going to the left. We describe x first and then the y, or the f of x. So because I'm going to the left, we're talking about x going to negative infinity. What is my f of x doing? Well, my graph is going up, so that means f of x goes to positive infinity. That's for the left half of the graph. All right, for the right half of the graph, notice we're going to the right. So as x goes to positive infinity, where am I going? I'm going up. So f of x goes to positive infinity as well. My next example is a cubic. You should recognize that parent function. All right, so I'm going to label my arrows first. This arrow is going down and to the left. This arrow going up and to the right. So because I'm going to the left, as x goes to negative infinity, where am I going? I'm going down. So f of x goes to negative infinity as well. On the right-hand side, we're going to positive infinity. So as x goes to positive infinity, I'm going up. So f of x goes to positive infinity as well. My last example, what happens when we approach an asymptote? So this is something different from our other ones. Now I am going to put arrows on this graph. You should recognize it as the exponential graph, and exponential graphs have horizontal asymptotes. So I just drew in the horizontal asymptote for you. So if you look on this arrow on the left-hand side, we're definitely going to the left, but am I going all the way down? No, I'm going down-ish. So kind of is what that means. So down-ish, not really going all the way down. All right, so we would say as x goes to negative infinity, because I am going all the way to the left, but where is f of x getting closer and closer to? It's not going to negative infinity because it's not going down. It's getting closer and closer to this y value, and that y value there is 0. On the other side, we are definitely going up and to the right. So we can write it like normal. X goes to positive infinity, or as x goes to positive infinity, f of x is also going to positive infinity because we are going up. We'll see lots of practice with that in class, but just to get your notes finished, there you go.